just like test one. And there will be 4 questions. So I think the first part will be on the register or the accumulator. Okay, I don't know which one, maybe the combination of those, register and accumulator. And then the other 3 question is regarding the FSM. Okay, maybe one question is asking about the Mealy to draw the state diagram. Another question is to fill up the state table, and another one is to do the analysis where you are given a circuit and you have to draw the state diagram from the circuits. Okay. And by looking at the last year questions, okay, this is 1819, so like 2 years ago. The flip-flop use is basically D flip-flop, but since we are also learn about JK flip-flop, I think it is not. It is still possible if the question is asking you using the other flip-flops like JK flip-flops and T flip-flops, right? Okay, shall we start on this? I have to make the screen smaller because I need to see the whole circuit here. Right? Hope you can see well. Okay. We only have 1 hour, so let's do this together. So this is my answer. This is my answer for because I don't see the answer scheme. So this is my answer scheme for semester 18-19. Okay, test 2. All right, let's look at questions 1. So question 1 say, given a custom made register as shown in figure 1.1. So this is the custom made register, right? And then analyze the register to determine the multi-mode operation by completing table 1. Okay, so this register has a 4 mode from input S1 and S0 here. So mode S1, S0 will do 1 operations. Okay. And we also have clear here, asynchronous clear. So we can first write this answer first. Okay, regardless of the modes. Okay, regardless of the modes, if the clear, okay, input clear is 0, okay, because this is active low, right? Okay, all states will be clear to 0. Okay. So the operations here is doing asynchronous clear, right? So in the test, if you don't know how to write asynchronous, just write async. Okay, I would understand that. All right. Don't waste your time looking on how to spell that. It's okay. Okay, now what happened when S1 and S0 is in mode 0, 0? So S1, S0 is 0, 0. S1 is the selector of this, of all of this multiplexer on the left, and S0 is the multiplexer on the right. Right? If S1, S0 is 0, 0, okay, Q0 will be chosen. But here, okay, this input will be chosen, 2D. Okay. So here, this is Q3 and S1, which is 0 bar, right? Because this is a NAND. So the next state for Q3 here is 1. Okay, because end with 0 will be 0, and then complement, it will be 1. Okay, let's see the others. Although this is here, then this is, so it's a pattern, right? So this one is Q2, Q1, and this is Q0. If the selector S1, S0 is 0, 0, okay, the next state will be 1, 1, 1, 1, right? So the operation is like we set all input to be 1, okay, or like a preset. So it's a synchronous preset. Okay, or maybe you can just write set all output, okay, or output equal to F. Okay, F is 1, 1, 1, 1, right? Okay. Acceptable. Okay. Set all output acceptable because set means 1. Okay. Output equal to F. So means the whole register output, okay, is F 1, 1, 1, 1. Also acceptable. Okay. And if you write synchronous preset, of course, that will be the best answer. Okay. The operation is synchronous preset. All right. Then let's look at if the mode is 0, 1. I'm going to erase all this first. Zero, 1. Okay. So this one will be choose. Go into the D flip-flops. 0 and 1. Let's choose. Hope you see the pattern here. So this is Q2. What's coming here is Q2. Yes. Out here is Q2. Here is Q1. Okay. Q0 and 0. Okay, which means Q2, Q1, Q0, 0. This is shift left. Shift left means we shift left 1 bit. Okay. If you say shift left how many bits, then it will be like more than 1 bit. Or we can say, okay, this could also be multiply by 2. Okay. Shift left 1 bit is equal to multiply by 2. Okay, so the operation or the function will be multiply by 2, or you can just say shift left. Right? So the circuit looks probably intimidating for some of you, but it's actually not that hard. Okay, it's very simple. You got one. Okay, you solve one flip flop here, and then it's the same pattern for all. Okay, because they are all connecting with the same clock, with the same similar multiplexer, okay, and the same selector. Okay, and if the selector is 1, 0, 1, and here is 0, and here is Q3 and 1. Okay, this is 1 here because it's S1. Now it's 1, 0. Q3 and 1 bar. Okay, Q3 and 1 is Q3, so it's just Q3 bar. So the pattern here is This one is Q2 bar, Q1 bar, okay, and also Q0 bar. Okay, so it's actually doing complementing. Okay, Q3 bar, Q2 bar, Q1 bar, and Q0 bar. So the operation is complement. Right? Or maybe you want to say bit inversion. Yes. Okay. You can say that. All right. Last one is when the mode is 1-1. 1-1. So we just change the color. It's easier. Okay. D going straight. So that's the pattern. So we get D3, D3, D2, D1, D0. So this is D